So today I will be explaining about task 1 Fourier series. For question 1, it involves a piecewise function, and for the first part A, this is the sketch that we get after plotting it at GeoGebra. Next, to solve the problem, we use the tabular method. By using the approach of Liate, the algebraic will be the one to differentiate, while the trigonometric will be the one to integrate. And solve this, we get 2 times negative 1 over n minus 2 over n square pi square. Next, we use the same method for the exponent x cos n pi x dx, and we get the answer sin n pi x over n pi minus 0. After that, for step 3, to find the Bn, we repeat the same steps as previously, and we can see here, Bn equal to 1 over 1 integral negative 1 to 1 fx sine n pi x over 1 dx. We separate it and we solve, we get Bn equal to negative 1 to 0 negative 2x sine n pi x dx plus 0 to 1 exponent x sine n pi x dx minus 0 to 1 sine n pi x dx. Then, using the same tabular method as we mentioned previously, by using Liate, the algebraic one will be the one to differentiate, and the trigonometry one will be the one to integrate. Solving this, we get the answer of 1 neg- times negative 1 n over n pi. Therefore, by substituting a naught, a n, and b n into the general Fourier series formula, we get that the answer is e negative 1 over 2 plus summation of 2 times negative 1 over n minus 2 over n2 times pi 2 plus exponent times negative 1 to the power of n minus 1 over 1 plus n square pi 2 times cos n pi x. Next, for the Fourier series for question 2, it involves piecewise function of pi and x square. And after sketching the graph using GeoGebra, this is the sketch that we get. Then, for determining the Fourier series of fx, as the period is L equal to pi, then we can substitute the value into the general Fourier series equation, and we get that fx equal to n naught over 2 plus summation of an cos nx plus bn sin nx. Then, to classify the function, because because f times negative x equal to negative fx, the function is odd. Therefore, n naught is 0 and n is also 0. Then, the half range Fourier series become Bn series. Fx equal to summation of Bn sin n pi x over L. Because of L equals to pi, then we get that Bn sine nx. Then, for finding Bn, we use tabular method as previously mentioned. Thus, we get that n pi equal to negative n negative pi square times negative 1 to the power of n over n plus 2 times negative 1 to the power of n over n cube minus 2 over n cube. Then we integrate and substitute the value. Therefore, we get that Bn equal to 2 pi plus 4 minus 4 times minus 1 to the power of n over pi n cube. Then, by substituting the value into the general form of Fourier series, we get that fx equal to summation of 2 pi over n plus 4 minus 4 times negative 1 to the power of n over pi n cube times sine nx. Lastly, for the last question of Fourier series, by sketching the function of fx using mathematical application, that is GeoGebra, we get the sketch of the sketching like this. Then, by determining the Fourier series of fx by the given period of L equal to 1, we get that fx equal to a naught over 2 plus summation of a n cos nx plus bn sin nx. Next, by classifying the function, we get that fx equal to a naught over 2 plus summation of a n cos n pi x. Then by finding the n naught, we get that n naught equal to 2 over 3. After that, for finding a n, using tabular method, we get that the a n is equal to 4 times negative 1 to the power of n over n square pi square. Then the Fourier series, after substituting all the value, we get that fx equal to 1 over 3 plus summation of 4 times negative 1 over to the power of n over n square pi square times cos n pi x.
I, Assalamualaikum. Now I will continue with task 2, which is to expand the given function into even and odd functions. Then determine its Fourier cosine series and Fourier sine series. First, the cosine series. This is the graph of the original function that defined from 0 to 4. For the interval from 0 to 2, the function is constant with value 4, while from 2 to 4, the function becomes x minus squared. First, we construct the even extension by reflecting the graph about the y-axis. Since it is an even function, only the cosine terms remain, so all the sine coefficients BL, Bn are equal to 0. Next, we calculate the coefficient A0 by using integration over the interval from 0 to 4. This is the integration. After simplifying the integration, we get an and a0. And after that, for the final answer, we obtain the Fourier cosine series that's shown on the slide. Next, for the sine series. For the odd extension, we reflect the graph with opposite signs across the y-axis. Since this is an odd function, both a0 and an become 0, leaving only the sine terms. We then calculate the bn coefficients, and this is the integration that's shown on the slide. And for the final answer, we obtain the final Fourier sine series that displayed in the slide. Next is task 3, harmonic analysis. In this task, we are given 12 data points over one complete cycle from 0 degrees to 330 degrees. These values are used to determine the Fourier series expansion up to the third harmonic. We first calculate the summation of yr, xr, yr cos xr, yr sin xr, yr cos 2xr, yr sin 2xr, yr cos 3xr, and yr sin 3xr. Since n is 12, sample intervals are over full cycle. We have to find A0, AN, and BN. And the aptitude first standard harmonic sequence format is given and shown on the slide, where C0 and Cn and alpha n is also to determine for the third for the three harmonic. For the first harmonic, we obtain the amplitude C1 and phase angle alpha 1. The same procedure is repeated for the second and third harmonic to obtain C2, alpha 2, C3, and alpha 3. For the first harmonic, since both A1 and B1 is more than 0, the angle lies in quadrant 1. However, for the second harmonic, A2 and B2 is below 0, so the angle lies in quadrant 3. But the third harmonic, the A3 is below 0, and B3 is more than 0, so the angle lies in quadrant 4. After combining all these three harmonics together with the constant term, we obtain the final Fourier series in standard form, as shown in here. This equation provides an approximation of the original periodic data using the first three harmonic components. That's all from me. Thank you.